The topic which we are going to see now is what we call as the knapsack problem. So what is the problem scenario here? Imagine a thief who is robbing a store and he can carry a maximum weight of W into his knapsack. Suppose there are n items available and the weight of ith item is Wi and its profit is Pi. What items the thief should take? See, there is an important point to note here. The item should be selected in such a way that the thief will carry those items for which he will gain maximum profit. So this knapsack problem we are discussing here, it comes under the greedy programming technique. The knapsack problem that comes under greedy programming technique is what we call as the fractional knapsack. That is, a thief can take a fraction of the item that he wants to carry. So what is the objective of the knapsack problem? The objective is to maximize the profit. So what is the problem here? Given a set of n items, each with a weight and value, determine a subject of items to include in a collection so that the total weight is less than or equal to the given limit and the total value is as large as possible. Right. So what is fractional knapsack? So the items can be broken into smaller pieces. Hence, the thief can selection a fraction of the items. So this kind of problem can be applied under greedy programming. So the knapsack problem that is discussed under greedy programming is a combinatorial optimization problem. The general algorithm is given here. So what is given here is there are n items with their respective weights, where the weights are given by W1, W2 up to Wn and the values are C1, C2 up to Cn. What is the goal of this knapsack problem? So if P is the problem of selecting items from n with weight limit W such that the resulting cost value is maximum. So rather than going for the general algorithm, it is better if we could just run through the general algorithm step by step and then go for a problem, solve it and then come back and look at the general algorithm. So I could just show a run through of the general algorithm here where each and every step has been given here. So how we are going to calculate the VI in step 1, and step 2 it deals with sorting the items by decreasing order of VI. Step 3 where we go for each iteration and choose the item I. So last important thing to be noted here is the algorithm may take a fraction of an item with weighs exactly k. Let us go for the summary of this. The summary is as follows. We have a knapsack that has a weight limit W. There are n items I1 up to In having weights W1 up to W1 and with respective values V1 up to Vn. So the second step is to calculate the value density, that is value density is given by the value of each item given divided by its corresponding weight. And the third step is after calculating the value density, you need to sort the items as per the value density in descending order, and finally we have to pick the items such that the benefit is maximum and the total selected weight is exactly W. Alright. So what is the pseudocode? This is the most important part of this fractional knapsack problem. So we have the algorithm fractional knapsack function where we have two arrays and a capital W. In the first array we will hold the weight of the n items and the second array will hold the profit of all the n items, that is the value of all those n items. So for each item we check this weight of the total knapsack. If so, weight will be assumed as 0. If choose each item and then go for the weight. If weight plus W of I is greater than or less than or equal to W, then X of I is equal to 1. Similarly, if it is not so, we can take a fraction of the item. And finally, we can return the value of X. Let us take an example here. So the capacity of the knapsack capital W is equal to 60 and there are 4 items A, B, C and D with their corresponding weights and their profits. So how to find out the solution for this particular problem? Step 1, you need to calculate the value density for each item. That is, weight is given, profit is given. Okay, so value density is nothing but the profit divided by its corresponding weight. So 140 divided by 40, 280 divided by 40 will be 7, 100 divided by 10 will be 10, 120 divided by 20 will be 6 and 120 divided by 24 will be 5. So once you calculate the value density, half the problem is almost over. The second step is to sort the items as per the density in decreasing order.